this is the wording they sometimes do on OSC. So, they don't want you to fail. We want to prepare you. Put that away here. Okay, so the first one says we want two rays that are connected by the same fixed point. What's it mean if it's a fixed point? It's stuck there and it's not moving. It's fixed into a spot. So you need to start with some fixed point. So everyone should have started with a point. It didn't matter where you put it. Here's my point. And then you had to have two rays that are connected by that point. So what do the rays have to look like if they're connected by that point? Coming out of it. So you could have come out of it any way you wanted. Here and here, for example. Those are two rays that are connected at a fixed point. The same fixed point. Now what did you actually draw? That is an angle. Next one. You want all points of a line that are between two fixed points of the line, including the two fixed points. So what did you have to start with? Two fixed points. Anywhere you wanted. Two fixed points. Here and here. Okay, and it says that they are connected. It says all the points of the line that are between there. All the points. Every single point that's between there. So if you think about that, every single point is, if you think of every single point that's in between there, every single one, what are you going to draw when you're all done? What is that? That is not a line. What is that? That is a segment. It's that two endpoints and all the points in between it. That is a segment. Two endpoints and all the points in between it. The third one says, all the points of a line that are on one side of a fixed point, including the fixed point. So what do you need to draw? A point. Now you need all the points on one side of it. Doesn't matter what side you go on. All the points on one side. Forever. What are you going to end up drawing? That is a ray, right? Because it's going to keep going. So this is a ray. So remember, when you get weird wording, just don't quit on it. Instead, just start drawing stuff that they say, because after you draw it, you're like, oh, I could see that that's a segment, or that's a ray, or that's an angle. Even if the words are weird. Okay, the other side. Now remember, on the other side, you could have used your yellow paper, or you could have used the paper that we did with the pizzas on it, because paper with the pizzas on it has the 7 angles right here. So it's nice right here. And it also reminds you which ones are from the same pizza and which ones are from different pizzas, right? Okay. So remember, you can do all of the things that help you. So some things that we have done to help us have been what? We have drawn little pizzas, correct? So we could think, is it on the same pizza or different pizzas? What else have we done? We have put A's and O's by all of these angles, right? And that way you can tell if they're congruent or supplementary, right? So you could have done that. What else have we done? We've colored. How might we color? Did we color the interior maybe? Okay, so coloring an interior is nice and quick because then we could quickly see who's on the interior, right? What else did we do? We also drew the transversal. I'll do mine in blue because you need to see if they're on the same side of that blue guy or alternate sides of that blue guy, right? So these are all little strategies that nobody tells you you have to do. But are they going to stop you from making silly errors? Probably, right? The person who does all of these things is clearly less likely to make a silly error, right? Okay, so let's look at A. I'm going to make a hot mess of different colors on this screen. I'll start with purple. 1 and 3. So if I find angle 1 and angle 3, I circled them in purple. Angle 1 and angle 3. Are those interior or exterior? Both. One of them is interior, one's exterior. So that means the interior and exterior types of angles are off the table now, right? You can't call them interior if they're both not interior. So don't use them. Like literally, once you color this interior, you can cross some people off right out. So it's not anything interior, it's not anything exterior. Are these guys on the same pizza?
Yes.
Look at them. They're not on the same pizza. 1 is on this pizza, and 3 is on this pizza. So they are on different pizzas. So what's the only angle possibility we have left? What do we got? Corresponding? Is that what you're going to say? So these are corresponding. Now remember, corresponding angles, if you cannot identify them, that's this guy. Do you see this purple piece of pizza and this other purple one? Corresponding are the exact same slice on 2 different pizzas. Aren't those the exact same slice? This piece is the same as that piece from the exact location. So these are corresponding, and are these guys what? What's the rest of this? We might as well finish it off. Angles are what? Congruent. Which, if you labeled those O's and A's, you can clearly see those are both A's, right? And these lines were parallel, so all of these rules work, right? Remember, they got to be parallel. Next one, I'll do green. We have 1 and 6. So find 1. He's right here. 6 is right here. What do you notice about 1 and 6? They're on the same pizza, aren't they? Okay, so you only have 2 options. The ones on the same pizza are which 2? Same pizza are vertical and linear pair. Those are the only 2 options. So are these 2 green guys vertical? The scissors across from each other? So these guys are scissors. These are vertical angles, and what's true about them? Vertical angles are congruent. They're both A's. Okay, next color, 7 and 6. I'm going orange. 7 and 6. 7 is here, and 6 is here. Okay, what do you notice about them? They're both in the interior. You see how easy is it after I've colored them? Like you can see my shaded yellow, right? What did I say? So they're both on the interior, correct? Okay, so they could be interior. Now, my next question is, are they on the same side or different sides of my blue transversal? Same side. So what do we call them if they're the same size? Same consecutive interior angles. And what's true about them? Was that 2 A's, 2 O's, an O, and an A? What? Equals 180. So these are supplementary. That was an O and an A. Next one, we got, I'm going to go red. 7 and 2. 7 is here. 2 is here. What do you notice about them? They're both interior, aren't they? Okay. They're on different pizzas. So that means that these 2 are off the table because they're different pieces, right? So they are definitely interior. Now, next thing you check, my transversal. Am I on the same side of my blue line or different sides? Different sides. So what do we call them? Alternates. Interior angles are what? Congruent. Those are both big obtuse angles. Next one, we got 4 and 8. I'll go black. 4 and 8. 4 and 8. Let's see, where are they at? 8's here, and 4's here. What do you notice about 4 and 8 right off the bat? They're on the same pizza, which means these are my only 2 options right here, right? Okay, so are they vertical across from the scissors, or are they a half a pizza? They are half a pizza. If I took this, if I ate this piece and this piece right here, that clearly is me eating that half a pizza right there. So these are linear pair. And linear pair is 180 or supplementary, right? 4 and 5. Let's see. I'm going to go blue. Where's 4? 4 is down here. 5's out here. Okay, what's true about 4 and 5? They're both exterior, right? They're both exterior. 4 and 5 are they on the same side or different sides of transversal? Different sides. So what are these guys? Alternates exterior angles are what? Congruent. The last one, we got 1 and 4. I'm out of colors. Let's go this nice little aqua blue. Okay, 1 and 4. Where's 1? Right here? 1 and 4. Okay, what do we see about 1 and 4? Both exterior. And they're on the same side of my blue transversal, both on the bottom side. So these guys are going to be what? Consecutive. Exterior are supplementary, right? Cool. How'd you do? Good? You got your things done. Okay. Let's do some algebra along with these. Yay! Okay, so I am going to actually take these for your daily accountability test. So just make sure your name is on it. Scoot it to the end of your table. I'll grab it in a second. But we're going to draw in our OMG right now on page 21. Some of you are already on page 21. Okay, so on page 21, here's what we're going to do on page 21, just so you can lay out your page. We are going to, on page 21, this is page 21, cut it in half in the middle like that. Cut him, because we're going to do 2 problems. The first problem is this one. So you're going to have to draw this picture here and put all your information, and we're going to be doing some algebra to the right of it. Okay? And then we're going to do a second one after this one. So I need you to draw this picture in your notebook. I'm going to grab your Bellworks as you draw that picture. Go to page 21, please. Draw that picture. Yes, you need all of those numbers and everything on there. We're going to have to do some algebra in here too, so don't make it too big. Yeah, beautiful. Now put the 3x plus 10 in there and the 5x plus 90 in there. Okay, I assume you have a nice drawing by now. Okay, so we're going to, whenever you're given a problem like this, you should always start with what you just started with on the bell work. Start by figuring out what kind of angles they are. Now, the only angles we have information about are this one and this one, right? So remember, do all of those things that might help you. You can shape the interior. You can make little pizzas. You can label them O's and A's. You can do all of those things to make sure that you name them correctly. So your first step on problem number 1, we're going to, first we're going to name the type of angle. So on your paper, write down what type of angles those 2 guys are. Just like you just did on the bell. What do these arrows mean right here? That means parallel. Remember that your congruence and supplementary rules do not always apply if they're not parallel. So double check. They either will tell you in words they're parallel, or they'll put symbols on the picture to tell you they're parallel. So these guys are parallel. What kind of angles did you name those guys? Consecutive exterior. Do you guys agree? They're definitely both exterior, because if you were to shade the interior, these are both exterior. These guys are consecutive exterior. And what's true about consecutive exterior angles? They are supplementary, correct? Okay, that's always going to be your first step. So decide what kind of angles they are. Even if they don't ask you what kind of angles they are, write down what they are, because then you'll know you're applying the correct theorem, postulate, whatever to it. Okie dokie? Okay, so I agree that they are consecutive exterior. Okay. The next step, just like we did on this paper with the pizzas, do you remember after we did that, we said these guys would be an O and an A, right? And then how would we write an equation for this? What did the equations look like for things that were supplementary? Okay, so we would do the angle, which he just said, all that junk, plus the other angle equals 180, right? Because that's what supplementary means. So this is how we would set up our equation. And he just named what the two angles are. So all we got to do is sub them in now, right? Angle plus angle makes 180. Okay, so let's go ahead and do this angle first. What's that? 3x plus 10. And then we need the other angle. And you can color code in your notebook, because this is a nice example that you'll be able to look at later. Next one is 5x plus 90. And that has to equal 180. So we just did a substitution property right there. And then you're going to do your algebra teacher proud. Go ahead, solve that. Don't say the answer out loud. You know what they would tell you to do next, right? Okay, so your teacher would have said to combine like terms, and you got what, 8x? And then any other like terms you had on that side? This guy and this guy are like, so plus 100 equals 180. And then what would you do? Minus 100 from both sides. And you would get 8x equals 80. And then you would divide both sides by 8. And you would get x equals 10. Okay. And you might be done. It would depend on what the directions are. But if this was a test, even if they didn't ask, you would plug it back in, and that way you would see if you're right or wrong. So we're going to take this x, because we need to find the angle measures, because this 10 is not the angle measure. It's just the value of x. So you got to plug them in. So go ahead and grab your calculator or multiply in your head. It's totally up to you. 3 times 10 plus 10. 3 times 10 plus 10. 40. So the measure of this angle is 40 degrees, which seems like a legit number. If you got something weird, it might not be good. And now we need to do this one. 5 times 10 plus 90 is what? 140. And how would we know if this is right or not? Yeah, because remember, we wanted them to be supplementary. So does 40 plus 140 make 180? So, okay, so then we don't have to ask anybody if that's right. We know we're right. That's how good we are. Okay, draw your next picture. I'm going to scritchy off some of the stuff on the picture, because this picture has a bunch of extra stuff you don't need, so don't get so excited about it yet. Don't get all worked up. Okay, let me get rid of the stuff you don't need to worry about. Okay, we don't care about the letters. We're not going to worry about naming stuff. We're just going to find the value of the variables. So we don't need the letters. You don't even need these little archy poo-poos. Because it's not like they have arcs with tick marks on them or anything, so we don't know if they're congruent. They're just saying that that's what they're talking about. Okay, he is less complex. But yes, all the stuff is left up there. Draw him in your notebook. You need both of those expressions for your X ones, and you need the Z and the Y. Draw the next guy. Okay, do you have a nice picture? Okay, so when we look at this, you see that we have X's and Y's and Z's. So you're going to have to pair up the common variables because you can't solve things with two variables unless you have a system of equations, which we're not dealing with. So you see the two guys that have the X. So we're going to worry about just them. So you might want to get a colored pencil. We're going to worry about just this guy and this guy because they have the common variable. So we're going to do the exact same step before. We're going to start by identifying what kind of angles those are. So look at those orange guys. So your first step, we need to write down, look at those guys, figure out what kind of angles they are. Write down whatever you think. And as always, you can shade interior. You can make the pizzas. You can label them O's and A's. You can do all of those things. Okay, what did you guys call these guys? They are corresponding. These guys are corresponding angles. And what's true about corresponding? Angles are congruent. And you could tell because this pizza, you see this slice we took out of that pizza? And this pizza, the slice, do you see how it's the exact same slice of pizza from both of them? That means they are corresponding angles. Okay, corresponding angles. So when we had our paper and we were trying to do an equation for corresponding angles that are congruent, what does congruent mean? Equals. So we put our equation look like angle equals angle. There was no 180 in this one, right? Because the 180 is only if things are supplementary, right? So those two guys have to be equal to each other. So we can plug those two in. So we'll make this first guy be the first angle, 5x minus 10. And that has to be equal to the other guy, 4x minus 2. And go ahead and solve. Do your little algebra. Okay, there's a big fine here, so see him? Be free, Mr. Fly. Go outside. It's okay. The fly has to go. It's right there.
No, that's fine.
Oh, that's a fuzzy. Did you see it though? Didn't it look like a fly?
Yes, we're gonna kill it.
I was going to step on it for sure. I do not have a problem killing bugs.
There was a sentence in Milwaukee. During my tennis match, I got yelled at because they were screaming about a stink bug and I killed it.
Yeah.
I felt bad that I killed it. Why did you feel bad? It's just...
I know. Because
No,
me up. They're ugly.
They literally woke. I was asleep and then they started screaming on the bus because it touched one of them.
Okay, how'd you guys solve this? What did you do first? Subtract 4x on both sides. I'm going to do that because if I have variables on both sides, I'm going to get rid of one of them. So 5x minus 4x just gives you 1x or x, right? Minus 10 is equal to what? Negative 2. Don't lose that negative over there. Then what? What'd you do next? Add 10 on both sides. So we have x on this side is equal to negative 2 plus 10, 8. And then what? We do definitely have to plug it back in because we need to figure out what y is and z. So we definitely need to plug this 8 back in for these x's. So that way we can get some angle measures. So we got a 5 times an 8 minus a 10. 5 times an 8 minus a 10. 30. So this angle is 30 degrees. Is that a reasonable answer for that angle measure? Sure. Now remember, pictures do not have to be drawn to scale, but you can't get something like 250. That doesn't even make sense, right? So we'll have some common sense, right? Down here, 4 times 8 minus 2. 30. Is that what we wanted?
Yes.
We wanted them to be congruent because we said so, right? Okay, so how do we get to either z or y? So look at your picture. We got to get to z or y. Let's just look at them for a sec. Does anyone have a plan for z? What kind of angles is that? They're on the same pizza. They're across from the little scissors, right? So these are. So put a little note over here. This guy, these are vertical angles. Same pizza, little scissors. Vertical angles are congruent, correct? So that means what is the value of z then? Also 30. Okay? So z equals 30. Okay? Now we need to get down to the bottom. To the y. Who has a plan for the y? Same pizza? What do you got? Linear pair. Is this a half a pizza? Sure is. So write linear pair. Don't put your book away. I'm going to give you a paper to put in there. It's a practice. Yay, you're welcome. Linear pair. What's true about a linear pair? They have to be supplementary, which means this 30, what does this guy have to be then? 150 degrees. Does that work? Yeah? Okay, I'm going to give you a practice paper. You don't have to finish it all tonight, but we're going to check it probably Friday. So you can do some of them